Good afternoon, students. Today in this unit, we are going to discuss about vector computation. This is one type of parallel processing we have discussed. Vector processing is another organization design decision in a multi-core system. So whether the individual cores will implement simultaneous multi-threading. Multi-threading means a thread is a stream of execution in a process. It is a light-weighted process. You will execute multiple program. What is a process? Process is a program in execution. Thread is a stream of execution in a process. It is a light-weighted process. It is very fast. That is the use of a thread. Now, to facilitate the simultaneous multi-threading, the Intel Core Duo uses pure superscalar cores, whereas the Intel Core i7 uses SMT cores. SMT has the same simultaneous multi-threading, that is SMT, has the effect of scaling up the number of hardware level threads that multi-core system supports. So the multi-core systems have 4 cores and SMTP supports 4 simultaneous threads. In each core appears the same to be in the application level. So as a software, it is developed in the fully exploit the parallel resources. The purpose of using SMT is for faster execution. So the structure of a vector unit consists of 4 lanes. Vector lane, one or more vector functional units and a portion of the vector register file. So it inspired by lanes on highways, the traffic signal speeds. Multiple lanes execute vector operations simultaneously. So, which is when we are standing in the signal, we will have in the signal we are have to pay and we have to be separated in a lane, right? So, like that, the same way the multiple instructions are executed simultaneously. This is the use of a vector lane. How we are standing in the toll booth to pay the amount. Like that, parallelly, various vehicles are standing, and like that, various instructions are found to be executed. That is the use of a vector lane. The vector lanes increases the peak through throughput, because the throughput is increased means what? The performance is automatically increased. So, of a vector unit by adding more lines, it reduces the number of clocks per vector instruction. So the number of clock cycle is it reduced means faster will be the execution. Both the applications of the architecture must support long vectors, otherwise they will execute so quickly that you will run out of the instruction. So efficient way to execute data processing problem, they are using the vector computation. So the vector computation is used for parallel processing. See here, A1 to A9. So totally how many? Like an array. Vector is a collection or a group like an array. So here multiple instructions are executed in a different lane. Here we are having 4 lanes, like how we are paying to the toll booth. The buses are standing on the line, right? So when we are coming to the college morning, we will stand up in the toll booth. No, likewise, parallelly, all are allowed to stand, check, and then the data is executed. So this is the purpose of using a vector lane 1, lane 0, lane 1, lane 2, lane 3, which comprises of FP and the pipe. So what is FP? FP is actually fetch cycle. The fetching the processor we use FP, and pipe 0, pipe 1, pipe 2, pipe 3 are the lane 1, lane 2. Like that in the top it is mentioned. No, likewise it uses register elements as separately, because all are not able to access the same register. So they are splitted 0, 4, 8. They are splitted in lane pipe 0. That is lane 0. Whereas in lane 1 we are having the registers 1, 5, 9. Likewise, it is all separated multiples of 4 2 power n times. It is splitted. Some formula we can use to separate the number of registers, because 12 registers we are having means we have to split equally for the 4 lanes, so that all can access in the register. Totally, the register is a common one, but all the lane cannot access in the same register. That is not possible. So we are splitting and giving. Again, the feedback is given back to the register to again compute. And finally, after the completion, we are having the vector load and store unit. Load is used to receive the data. Store is used to send the data and store the answers. So this is a vectors with 4 lanes. The performance are using multiple functional units. It is used to improve the performance of a single vector. Example, the instruction C is equal to A plus B. It is happening in the single vector. The register A and the register B content are added and stored in the register C. So the lane 2 will not use the same register. So to increase the performance, we are splitting the work and doing. That's all. But there is a disadvantage in the vector processing. There were very concerns, many concerns about the largest data vector registers. Context switch time. That is, if you want to switch over from one work to another work, it is very difficult to store the data and the vector register. So it has mainly three functional units. What are they? Is FP add, FP multiply, load, and store unit. Each of the vector arithmetic unit comprises of four execution pipelines, one per lane. So each lane will use us one execution pipeline. So this is using a single vector instruction. So this is all about the vector composition. So it is introduced to increase the performance, but there are some difficulty. To some extent, we can apply based on the requirement. That's all. Thank you, students.